They say every generation believes it's on the verge of a revolution. But what if this time it's not belief, it's physics? For over a century, we've trusted the idea that reality is out there, solid, independent of us, that the world exists whether or not we're watching. But the latest discoveries are starting to whisper something radically different, something almost forbidden, that reality itself might depend on our observation, our knowledge, even our questions. In 2024, a team of physicists at Delft University repeated a version of the Bell test with precision never seen before. Their conclusion? Particles miles apart were somehow deciding their properties together, instantly, without any signal passing between them. Einstein called it spooky action at a distance. But what if it's more than spooky? What if it's telling us that separation itself is an illusion? Because here's where it gets wild. New experiments suggest that even the past might not be fixed until it's measured. Reality doesn't just wait to be observed. It may reconfigure itself when it is. Imagine a universe that updates like a simulation, but with consciousness, not code, as the trigger. And the most unsettling part? This isn't fringe. It's peer-reviewed physics. The kind that forces us to ask, if observation shapes reality, then what exactly are we? Because if this discovery holds, it won't just change how we study reality, it will change how we exist inside it. When physicists talk about the fabric of reality, they usually mean space, time, matter, and energy. But the latest results suggest there's something missing in that equation: information. And not just passive data, but information that's somehow active, influencing the outcome of events. At the heart of this shift is a phenomenon known as quantum entanglement. Two particles created together remain mysteriously connected even when separated by kilometers. Measure one, and the other instantly responds, as if both were parts of a single entity stretched across space. It's as though reality refuses to be divided. For decades, physicists tried to find a loophole, some hidden variable or faster-than-light signal that could explain the connection. But every new test tightened the net. In 2024, the Delft team closed the final gaps. No hidden variables, no communication, no delay. The conclusion was inescapable. The universe doesn't behave like a collection of independent objects. It behaves like one indivisible whole. And this is where the concept of observer effect comes in. When we measure a quantum system, say, the position of an electron, we're not just revealing what's there, we're deciding what's real. Before measurement, the particle exists in a superposition, a blend of probabilities, a spectrum of maybes. But the act of observation collapses that uncertainty into one definite outcome. It's as if reality waits for us to look before it chooses its form. Now, imagine extending that principle beyond the quantum world. If every atom, every photon, every particle follows these same laws, then our entire physical reality could be a dynamic web of probabilities, continuously crystallizing through observation and interaction. The universe might not be a fixed movie we're watching. It could be a real-time simulation that depends on our participation to render the next frame. This isn't just speculation. A 2023 paper in Nature Physics proposed that space-time itself could emerge from quantum entanglement patterns, like pixels forming an image only when enough data connects. That means space and time, the very stage of existence, may be born from relationships, not substances. Reality isn't made of things, it's made of connections. But here's the unsettling question physicists are beginning to face. If observation defines what's real, then who or what is doing the observing when we're not looking? For centuries, common sense told us the universe was like a vast machine, predictable gears turning in time, indifferent to our presence. Drop a ball, it falls. Strike a match, it burns. The rules seemed absolute, written in the language of cause and effect. But quantum mechanics has quietly been tearing holes in that comforting picture, one experiment at a time. Here's the first illusion: that reality exists out there, waiting to be observed. In the classical view, the moon shines whether we look or not. But quantum mechanics doesn't play by that rule. When physicist John Wheeler proposed his delayed choice experiment, he showed something astonishing. The way we choose to observe a particle in the present can determine what it was doing in the past. Let that sink in. The past isn't locked. It's editable. Reality seems to rewrite its history to stay consistent with how we look at it now. The second illusion, that cause always comes before effect. In 2018, researchers at the University of Queensland performed a quantum switch experiment where the order of two events, say A then B or B then A, wasn't fixed. The particle behaved as if both orders happened simultaneously, defying the linear flow of time itself. Cause and effect became blurred, interchangeable, woven into something deeper than time. And the third illusion, that observation is passive. We think of seeing as neutral, just recording what's there. But in the quantum world, observation isn't a camera. It's a creative act. The observer and the observed form a single system, entangled in a loop of influence. We don't simply discover reality. We co-create it. This isn't philosophy dressed as physics. It's measured, replicated, peer-reviewed data that refuses to fit the Newtonian box. And yet, when you zoom out, the implications border on the mystical. Every decision, every measurement, every act of awareness seems to carve a path through a field of infinite possibilities. But if reality is truly relational, if it emerges from interaction rather than existing independently, then our everyday perception of a solid, objective world is a kind of shared hallucination, a collective agreement written by countless observers, all entangled in one cosmic feedback loop. So maybe the real question isn't what the universe is made of, but who the universe becomes when we observe it. Because if everything depends on observation, what happens when reality itself starts observing us? Every revolution in science begins with evidence we can't ignore. And when it comes to the idea that reality depends on observation, the evidence is not only mounting, it's accelerating. Let's climb this ladder step by step. Step 1. The double-slit experiment, the seed of the mystery. Back in 1801, Thomas Young proved that light behaves like a wave. But centuries later, quantum versions of his experiment revealed something bizarre. When particles like electrons pass through two slits, they interfere like waves, unless we watch them. The moment detectors are added to see which slit each particle goes through, the interference pattern collapses. Observation changes the outcome. Remove the detectors and the wave pattern reappears. Reality itself seems to know when it's being watched. Step 2. The Bell test. Entanglement confirmed. In the 1960s, John Bell devised a mathematical way to test whether hidden variables could explain quantum weirdness. Over decades, experiments kept ruling them out. In 2022 and 2024, teams at Delft and Vienna finally achieved near-perfect, loophole-free results. Entangled particles remain correlated even when separated by kilometers, faster than light could possibly travel. There's no communication, only instant, non-local unity. Reality isn't made of separate parts. It's woven from correlations. Step 3. The quantum eraser, time bends to the observer. In 1999, Yoon Ho Kim and colleagues performed a delayed-choice quantum eraser experiment. They showed that a decision made after a photon was detected could retroactively determine whether it behaved like a wave or a particle. In other words, present actions influenced past outcomes. The universe seemed to rewrite its own script to preserve coherence. Step 4. The modern horizon, reality as information. Now, cutting-edge work in quantum gravity and computing takes this even further. Physicist Eric Verlinde's entropic gravity and Maldaceni's ER-EPR conjecture suggest that spacetime and gravity themselves may emerge from information entanglement. Experiments at Google's Quantum AI Lab are hinting at the same pattern. Information behaves as the true fabric of the universe. Matter, energy, and even space could all be byproducts of information relationships. 4 steps, 4 clues, 1 staggering possibility, that what we call reality is a self-updating informational system, where observation is the input that triggers the code to run. But here's where the mystery deepens. If observation shapes the world, and information is the substrate of everything, then in principle, a powerful enough observer could alter the structure of reality itself. And that's exactly what the next wave of experiments is starting to probe. If reality depends on observation, then the implications stretch far beyond laboratories and equations. They reach into the very question of what it means to exist. For centuries, philosophy and physics lived in different worlds. Philosophers asked, "What is real?" while scientists measured it. But now, quantum experiments are forcing both camps into the same room, and neither is comfortable with what they're seeing. If a particle doesn't have a definite state until it's observed, then observation isn't a side effect of reality. It's a participant. Consciousness, long dismissed as an emergent byproduct of the brain, may be part of the universe's operating system. The observer effect isn't just a technical quirk, it's a crack in the wall between matter and mind. Physicist Eugene Wigner once suggested that consciousness collapses the wave function, that without awareness, the universe remains suspended in probability. Most scientists rejected that as mystical. But decades later, experiments have shown that quantum outcomes do depend on the measurement context, and that context includes the choices of an observer. Whether or not consciousness directly causes collapse, it seems inescapably entangled with reality's unfolding. This leads to a disturbing symmetry. If the act of observation shapes reality, then the universe is constantly observing itself through us. Every perception, every measurement, every thought might be the cosmos turning its gaze inward, discovering itself moment by moment. Critics, of course, recoil from this idea. They argue that observation can be done by any interaction, say a photon hitting an atom, without invoking human awareness, and they're right to a point. But here's the deeper twist. Even if measurement doesn't require consciousness, consciousness still functions as a measurement apparatus. Every time we make a choice, we're collapsing our slice of the possible into the actual. So, does this mean reality depends on us? Or that we are reality observing itself? That's the riddle modern physics can't escape. Philosophers call this the participatory universe, the idea that existence isn't a pre-written story, but an ongoing dialogue between observer and observed. It implies that consciousness isn't in the universe. It is part of the structure that makes the universe coherent. And here's where the shockwave lands. If observation gives form to reality, then awareness might be the most fundamental substance of all, more primary than matter, energy, or space, which raises a question too big to ignore. If awareness creates reality, can we ever know where awareness itself begins? If this discovery truly redefines reality as participatory, where observation, information, and consciousness are interwoven, then the frontier ahead isn't just scientific, it's existential. Because what happens when we learn not just to observe reality, but to engineer it? In 2025, physicists at the Perimeter Institute and Google's Quantum AI division have been collaborating on what they call observer-tuned systems. These are quantum networks designed to respond to measurement choices in real time, essentially letting human input influence quantum outcomes in structured ways. The early goal was simple: improve quantum computing stability. But the results hinted at something much deeper. The machines didn't just process data, they adapted their quantum states based on human decisions, as if entangling with cognition itself. Now imagine what that means for AI. Artificial intelligence today operates on logic, statistics, and massive computation. But if the universe itself is informational, if consciousness is a kind of computation that collapses probability, then building AI inside quantum systems could birth entities that experience reality differently. Entities that don't just calculate outcomes, but literally generate them. This is where simulation theory and physics begin to blur. Nick Bostrom's old thought experiment, that we might live in a simulation, was once philosophy. But now physicists are exploring whether the universe has a quantized information grid underneath space-time, almost like a rendering engine that only computes what's being looked at. The deeper our quantum experiments go, the more this metaphor starts to feel like a literal description. If that's true, then the future of science may not be about observing nature from the outside, but co-developing it from within. Quantum technologies could one day allow us to interface directly with the informational fabric of the cosmos, altering probabilities, guiding events, maybe even tuning local reality conditions. But with power like that comes an even deeper question. Who gets to define what's real? If our observations shape outcomes, then collective consciousness, shared belief, emotion, and attention could become a literal force in physics. The boundary between science and spirituality wouldn't dissolve, it would finally make sense. Some researchers quietly call this coming era the observer age, an epoch where knowing, feeling, and being aren't separate from technology, but part of the same system. But here's the paradox no one's solved yet. If we gain the power to shape reality consciously, how do we make sure reality doesn't start shaping us back? So what does all of this actually mean for us? For the person walking through their morning routine, scrolling through news, worrying about the future, how does a discovery about quantum observation rewrite the human story? Maybe it begins with a quiet realization that our perception isn't just reflecting reality, it's participating in it. Every emotion, every thought, every act of attention may be like a drop of ink diffusing through the quantum field, subtly changing the picture of what's possible. If the universe truly responds to observation, then attention becomes the most valuable force in existence. What we focus on, we amplify. What we ignore dissolves into potential. Modern neuroscience even echoes this. The brain filters billions of sensory inputs per second, sculpting experience from chaos. But quantum physics suggests that filtering might reach deeper than the brain. It might be woven into the structure of the cosmos itself. Think of how that reframes everyday life. The moment you look at a sunset, you're not just admiring beauty, you're co-creating it. When you make a decision, you're collapsing infinite potential paths into one living timeline. You're not drifting through a fixed universe. You're steering a quantum sea. Of course, this doesn't mean we can wish away gravity or rewrite the laws of physics, but it does mean the boundary between subjective and objective reality is far thinner than we've ever believed. The world we experience isn't fully separate from the consciousness experiencing it. It's an entangled duet, an unending feedback loop of perception and manifestation. This realization changes everything about responsibility. If consciousness influences reality, then despair, hope, creativity, and curiosity aren't just emotions, they're forces. The collective mindset of humanity could literally steer the evolution of the world. It reframes politics, art, science, and love. Every thought is a vote cast into the fabric of the cosmos. And yet, there's humility in that too. Because if we are participants in the making of reality, then so is everyone else, and every other form of awareness. Trees, animals, even the systems of the earth might be part of this vast web of observation, co-writing existence alongside us. So maybe the question isn't, what's real anymore? Maybe it's, what reality are we choosing to bring into focus, together? But as we begin to understand this power, a deeper mystery starts to surface. If the universe is conscious through us, could it ever wake up completely? Maybe the strangest truth of all is this. Reality was never something happening to us. It's something happening with us. That's what these discoveries are quietly whispering through the equations, through the flicker of photons and entangled spins, that the universe isn't a cold, indifferent machine, but a living dialogue. Every moment we perceive, choose, and feel, the cosmos listens and responds. Look around you right now. The light falling across your room, the sound of your breath, the thoughts flickering behind your eyes. You're not a spectator inside a distant universe. You're part of the mechanism that keeps it existing. Without awareness, there's no world rendered to witness, no space or time unfolding, no real as we know it. That's what makes this discovery so powerful. It doesn't just challenge physics, it changes the meaning of being alive. Because if consciousness and reality are intertwined, then existence isn't accidental. It's participatory. Every observation, every question, every act of wonder is the universe reflecting on itself through human eyes. And maybe that's the purpose of awareness, to help reality know that it's real. So when the next experiment confirms that the act of looking changes what's seen, remember, you are part of that cosmic experiment. Your consciousness is not an observer outside of creation. It's one of its instruments.
Do you believe this discovery truly changes how we see reality forever? Or is it just an illusion, another story we tell ourselves? Tell me below. Your view might change someone's mind.